Hello mathematicians, today's lesson is called Linear and Nonlinear Functions. Our learning target today is I can identify linear and nonlinear functions. Vocabulary. So we have the vocabulary word linear functions, and we know that linear functions have graphs that are straight lines. Nonlinear functions have no rate of change, maybe it's not a straight line, maybe there's no covariance, and it's not in the form of y equals mx plus b, ax plus by equals c, or point slope form, y take away y1 equals m multiplied by the difference of x and x1. So if you see something like an exponent in an equation, or let's say you see a graph that is curved or not a straight line, or you could see a table that doesn't have a constant rate of change, that is an example of a nonlinear function. Determine whether each table represents a linear or nonlinear function. Explain. So we're looking for a constant rate of change. So let's start with a graph on the left-hand side. So the change from 50 to 35 is negative 15. From 35 to 20 is negative 15 again. And from 20 to 5 is negative 15. From 2 to 4 is an increase of 2. From 4 to 6, increase of 2. And from 6 to 8 is an increase of 2. So the rate of change is negative 15 over 2 the entire time. So this does have a constant rate of change. So this table represents a linear relationship. So it's linear because it has a constant rate of change. Now for the next table, let's look for the change in y. So from 1 to 16 is an increase of 15. From 16 to 49, let's find out what that is. 49, take away 16. 3 is a change of 23, an increase of 23. From 49 to 50 is an increase of 51. Okay, so let's look at the change in x. From 1 to 4 is positive 3. From 4 to 7 is positive 3. And from 7 to 10 is positive 3. Now let's look at the ratios of 15 over 3 and 51 over 3. So the ratio of 15 over 3 equals 5, but 51 divided by 3 is 17. So they don't equal each other. This table does not have a constant rate of change. Therefore, it's nonlinear because the table does not have a constant rate of change. Use the table to determine whether the minimum number of calories a tiger cub should eat is a linear function of its age in weeks. So below we have a table, and let's find the change in y over the change in x. So the minimum calorie intake for a tiger that's 1 week old is 825. During its second week of age, it needs 1,000 calories. So this is a difference of 175. And the age is only changes 1 week. From 2 to 3 is 1, from 3 to 4 is 1, and from 4 to 5 is 1. Now from 1,000 to 1,185 is an increase of 185. During week 3 to week 4, we go from the minimum calorie intake of 1,185 calories to 1,320 calories, and that's a difference of 135. And the last difference is 100. Okay, so I noticed right away that 175 over 1 does not equal 100 over 1. So this function is nonlinear. A square has a side length of s inches. The area of the square is a function of the side length. Does this situation represent a linear or nonlinear function? Explain. So I'm going to start by drawing a picture of a square. So remember that a square has 4 sides. All the sides are the same length, and the angles are all 90-degree angles. Okay, so I have my square, and I know that one side is S, and all of the side lengths are S. The area of the square is S multiplied by S. We know that S multiplied by S is S squared. So the area of the square is S squared. Okay, so let's do some guess and check, and let's figure out if this is a linear or nonlinear function using a table. So if I have a side length of 1, 2, 3, 4, and 5, what would the area of each of those squares be? So for a side length of 1, the area of the square would be 1 times 1, or 1 squared, which is 1. The area of a square with a side length of 2 would be 4. 3 times 3 would be 9, 4 times 4 is 16, and 5 times 5 is 25. Okay, so I can look at the rates of change in y over change in x, and the ratios of those changes, and determine if it's going to be linear or nonlinear. So if the ratios are equivalent, it's going to be a linear function. If the ratios are not equivalent, then it's going to be nonlinear. So from 1 to 4 is an increase of 3. From 1 to 2 is an increase of 1. So 3 over 1. And then from 4 to 9 is 5, and from 2 to 3 is 1. So 3 over 1 does not equal 5 over 1. So right away, immediately, I can see that this is a nonlinear function. But now let's graph it, just to see what it looks like. So I'm going to make 2 units worth 1, 2, 3, 4, and 5 on the x-axis. And then on the y-axis, I'm going to make each unit worth 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and I think I only went up to 25, so that's probably good right there. Now let's graph those ordered pairs. So 1, 1 would be right here. 2, 4 would be here. 3, 9 would be here. 4, 16 is there. And 5, 25 would be right there. Now, if I have a side length of 0 and I multiply 0 by itself, the answer is 0. So this function does pass through the origin. But as you can see, I can't draw a straight line from, well, I could actually draw a straight line, but it wouldn't pass through all of the coordinates. I can't draw a straight line from 525 through 0 and have it pass through all of the coordinates. It just doesn't work. Okay, so this is a nonlinear function. When graphed, it doesn't form a straight line. It does not have a constant rate of change either.